Yes. Okay. Hello, my name is Elena Volkova. I'm a software architect in this team, and I will show you the new tracing feature. This feature is implemented in the backend library in Target RTS, and it is available when you run your application, and it is independent of the normal model debugger that we have. Also, this feature, since this is Target RTS and this is a common component in model real-time and code real-time, then this feature is automatically available in both products. This is a page document with the documentation about tracing, and now let's see how the tracing works. First, let's check how it works in model real-time. So in model real-time, I have a simple model, PyComputer. It is computing the value of pi number. So there is a top capsule, and there are two capsules, multiplier and adder, which are interacting, sending messages, and computing the value of pi. The tracing feature, it is by default available in your Target RTS library. So the binary, the library contains the functions for the tracing, but when you run your application, it's not turned on by default, it's turned off. So to turn the tracing on, there are several options how to do this. First, when you start an application, you should add a command trace on to your run configuration. So let's see, I have a run configuration for PyComputer, and in the command line arguments, I'm using -urts debug equals, and then I type trace on, semicolon, and then quit. This means that we are quitting from the RTS debugger. So we will run our application without any interaction, just from the beginning till end. But in the very beginning, we are turning the tracing feature on. So now I will run my application. I have it already pre-built. So this is the output from the application, and we can see that in the first line we get this additional message, tracing is on. It means that from the very beginning we have turned on the tracing. Tracing will print messages that are delivered between capsule parts in the application, and it will store it in a file. The file will be present in the same folder where you have your executable. So for PyComputer, we can go to default folder, and here this is our executable.exe, and this is the trace file that was just produced. This is a textual file, so let's first observe how it looks like in a textual editor. So you can see that it records and traces messages, the messages that are delivered to a certain part in your model. The syntax, currently, it is compatible with this JS sequence diagrams web resource, and it is quite simple. So first you get the name of the sender, then there is an arrow, then the name of the receiver, then there is a colon, and then a message that is delivered. So even in this textual format, it is quite readable. So you can see, observe, and compare. So if we scroll down, we can see that at the end, our application produced a result of type double, and it is the value of pi, and it was computed in there were 100 iterations, and after 100 iterations we got this value. So now let's try to visualize it in a sequence diagram. Currently, the only way to visualize is to use a web browser and use this JS sequence diagrams resource. So I will just copy this trace, and I will go to this web browser and paste it into this window, and we can see how the trace looks like on a diagram. So here you can see lifelines. Application, this is our top application. This is the name of the capsule. Then there are two more lifelines, adder and multiplier. And we can see all the messages coming back and forth, visualized. And at the end, we can see the result sent back to the application. So I see that there is a question. Do you have any question, Ingo?
Yes, thank you so much. Regarding activating this feature, I just can activate it overall, correct? So if I have a really large model, it will trace everything. So there's no possibility at the moment to say, okay, specified capsule just should be traced.
If you want just one capsule, currently this is not possible to configure which capsule or which capsule instance you want to trace. But this is very first version of this feature, and we have big plans to extend this. And we would be, it's very useful for us to hear your feedback on what exactly would you like to see from these traces. Currently, there is only an option to turn it on and turn it off. So it's not necessarily to turn it on for the complete execution of your application, but you can turn it on in the middle. For example, after you can set a breakpoint in your application, and after reaching that breakpoint, you can turn tracing on. Then you can keep it on for some time, and then you can turn it off when you have passed your problematic part of the model, and then you will get a part of the trace, not a complete trace.
Okay, so far so good. Yeah, I think there was something I can turn it on with RTS API. Is this correct?
Yes, and that is, I will show it right now. How
okay,
you
thank
can
you so
do
much
this.
for the moment.
Yes. So just a couple of more words about this, what you see. So currently, if there are several instances of a capsule, then you will get only one lifeline. So, and we have plans to improve this, so you will be able to distinguish between capsule instances. Currently, there will be only one lifeline, and all the messages will come to the same lifeline, even if it is delivered to different capsule instances. For example, you can notice when you incarnate several instances of a capsule, you will get several initialized messages delivered to the capsule. Also, one point is that a trace is written to the file when a message is delivered. So if you send a message and it is lost, it is not delivered, then you will not see it in the trace at all. And also you can see that on the left, there are two lifelines, system and timer. Those are special lifelines. They are always available. System, usually it's special system messages. In most cases, it's this initialized message when we incarnate an instance and an instance gets a message to initialize. And there is one instance timer, which is responsible for all timers that you set during the execution. And this, you will usually get timeout events from this timer instance. So now let's see how we can turn traces on and off in the middle of the debugging. First, let's try to do it from Model RealTime, debugger. So now I will, so this is stopped. Now I will start a debug session for PyComputer. We can see here in the description, in the documentation, that there are commands that are supported by RTS debugger to turn tracing on and turn tracing off. So this is the trace command. You can also run it without an argument, and in that case, you will just get the status of the tracing, if it is on or off. And the same commands, they are available from Model RealTime Debugger. Store. Yes. I will restore my previous session. So now here, I will just open a trace, but this is not the same trace as what I'm describing now. So this is a different trace that is produced specifically by the model debugger. But this view will give you a button, send to application. And this button can be used to send trace events that will turn this internal tracing to message sequences. So I will start an application. I think I should have a breakpoint. I will run. Yes, now I have hit a breakpoint in my multiplier. So before turning trace, I can resume and run application several times. Now, if I want to turn the tracing on, then I can type trace. First, I just type trace and I see the current status that currently tracing is off. Now I type trace on and now tracing is on. Now I can come back to my development session and I will press this several times more. This tracing command will also flush the trace into the file. So I need to mention that we don't flush a tracing event for each event. So when you are using these trace commands, then flushing to a file will happen only when you really use the command. So now I will turn trace off, and this will also flush all the events that I have received so far into the file. So maybe we can, even at this point, try to observe what is inside the trace. So let's just see. This is the trace file. I will open it in the text editor and I see that I got 3 events. And now I also see this additional message, additional note saying that tracing is paused. It means that we have turned tracing off after it was on for a while. So now we can come back to our debug session. I can turn tracing on again by this command trace on. Now I will do several more steps. 1, 2, 3, 4, 5, 6. And now I want to stop my application. So, but before stopping, I need to flush my trace. So I will send the trace event again to my application. I see tracing is on, but at the same time, I have just flushed my trace. So let's see what is in the trace. Yes, there are more commands here in the trace. And also, if I will turn the tracing off again, trace off, I go to my trace file and I see this note comes again. So now I can stop my debug session if I have got all the necessary information in my trace, and I can read this directly. I can also try to visualize it again in this web resource. So currently I need to scroll and just paste my result here, and we can see how the tracing looks like, a partial tracing can look like. So I pressed several times resume, then I paused my tracing, I continued debugging, then I turned tracing on, then I paused it again. And you can see it visualized in this trace. So now let's switch to code real-time. And in code real-time is using the same target RTS library. It means that this functionality, tracing functionality, is also available here. And it's very similar. So here, let's see a ping pong example. And now I have already a built version, a pre-built executable. It is here. And I will show you how to do this from the command line. I will open it in the terminal. Now I can see where is my executable. It's top.exe, top.exe, and now minus urts debug. Now I don't want to start it with an RTS debugger. I just want to turn trace on from the very beginning. And I'm using the same command. It is important to use quotes here in order to save this semicolon. So to have a semicolon to be a part of the command line argument. So I do it like this, and I will run my ping pong sample. I will wait for some time. It is running forever. And there is a timeout event before sending each ping and pong. There is about 1 second timeout between ping and pong. So now I will press Ctrl+C, I will stop it, and I can see the trace that I have received. It looks the same, of course, and now I also can use a simple web browser and paste my trace here and see how I can visualize the trace in code real time. So it is very similar. What we can observe is the timeout event, which is delivered before each new ping is sent, and pong is immediately sent back. And the timeout event, it comes from this special timer actor, which is always available. And also, if you want to trace some part of your execution, if you want to get a trace for some problematic part, then there is an interface. Target RTS provides an interface for doing this. There are commands, currently these 3 commands, provided by RTTracer header file. Set enabled, that will turn tracing on and off. Is enabled, that will check if the tracing is enabled or not. And flush trace, sometimes you need to flush your trace. You remember I told that for each event, when we receive events, they are not automatically flushed. But if you want them to be flushed at some point, you need to use this function. So we can now go to our ping pong sample, and first I will show you how to, you can do it even programmatically from your code snippets. So in order to do this, I need to add and include to rttracer.h file. I will use an implementation preface, and I will include this rttracer.h. This is a new file that is now available in Target RTS. And now what I want to do is, for example, here, each time I get a pong, I want to control programmatically my trace. So I will use the commands that I have just shown to enable and disable trace. So what I do is when count is 7 or 12, I enable a trace, and when it is 3 or 10, here I disable, here I enable. So it means that from 3 to 7, I will get my tracing, and from 10 to 12. So now I save it, and I need to build it again. And even I can run it immediately, because now I don't need to use a command line for turning trace on and off, but I did it programmatically directly from my code, from my model. So I will run it. It should build first, because I changed the code, and it will start to run. So build is completed. Now we run the application, and we remember that we need to wait until count 12, for example, and then we can stop our application. Now I can stop it. I press Ctrl+C. Now I stopped it. And now let's observe what we got in the trace file. So here I can see that I programmatically controlled my tracing, and I got it from 4 to 7 and from 11 to 12 as expected. We can also visualize it and see how it looks like on a diagram. And this is my partial trace from ping pong. Now you see that the system trace is on the right. I need to mention that currently there is no way to control the order in which you get the lifelines. So the order of the lifelines will be controlled by the order in which they appear in the trace file. But this, everything related to the UI, this is a big next step that we plan to implement. So there are a lot of ideas about how to improve and get more value from the tracing. For example, putting timestamps, supporting port names, supporting capsule instances, instance numbers, and so on. And your feedback is very welcome in this area. So this is a very first version. And finally, I would like to mention that the commands that I have just shown to you to enable and disable trace, they also can be executed from the C++ debugger. So you so you can get your application, you can open it, build it with the debug symbols, then you can open it in a C++ debugger. And for example, a Visual Studio C++ debugger allows you to use an immediate window where you can run certain functions. So you can call these functions and you can control your tracing even from the C++ debugger. So that's all from me. Any questions or comments? Yes, I see, Bart, you have a question.
Yes. Have other visualization tools also been considered? More specifically, plant UML, because I think the syntax is very similar. It integrates very nicely with VS Code using existing third-party plugins. I think that's even more convenient than having to copy-paste everything to a website. So it will allow you to use this feature offline as well. And it will also allow you to specify the order of the lifelines. So that might be an interesting alternative to consider.
Yes, definitely. This is just the first step. And basically, before we don't have anything, we have only trace. We are using this format, but it doesn't mean that the format is fixed. We will continue to work on the format and extend it. And of course, we will be considering other formats and other ways to visualize and also work on our own solution.
So there are, I think I can envision a scenario where we actually support more than one format, depending on what your purpose is. So there are benefits and drawbacks of the different formats. For example, there is the common trace format, which is supported by Trace Compass, which is something we are looking into. It generates a very different view than this, but I think also it has its value. And fortunately, I think the format is the smallest part here of getting. That's very easy to change the format and support multiple.
Yeah, indeed.
Yes, I also would like to mention that Trace Compass we also considered, but we noticed that this is a binary format. So one of the benefits is also to get this as text. And of course, we are planning to support more than one format. So this is just a first step.
Yeah, okay, thank you.